Hello students, welcome back once again to our Easy Chemistry channel. Today what we'll be doing is a very common topic which is called electrochemical cells. However, before we go into the topic, कुछ छोटी छोटी बातें कर लेते हैं. हमने अभी तक ये कवर कर लिया कि इलेक्ट्रोकेमिकल सेल क्या होते हैं और इसका जवाब ये है कि दे आर सेल्स विच आर capable of discovering or transmitting electric charges through them, which means an electrochemical cell is a cell which produces electricity with the help of chemicals. The chemicals which are present are namely called as electrolyte and electrolytes and solutes. Electrolytes also known as solvents. We can analyze the difference or analyze the entire process when we say that solute plus solvent gives us a solution, and that solution is electrochemical in nature, which means any solution or any liquid or any electrolyte or any solvent which is capable of transmitting electric charge through them are referred to as good electrolytic solutions or good solvents. So today when we move further in our journey in chemistry, we will be covering the topic of Bohr's atomic model. The postulates have already been discussed. So today we are starting off with a new subpart which is called as molality. मेरे प्यारे बच्चों, what we study or what we see is, अगर रूम टेम्परेचर पे एक गिलास पानी में हमने एक चम्मच कॉमन सॉल्ट डाला तो देयर आर चांसेस कि वो पूरे का पूरा कॉमन सॉल्ट जो है वो सोल्यूट में मिल जाएगा और वी हैव अ होमोजेनियस सॉल्यूशन. व्हाट इज अ होमोजेनियस सॉल्यूशन? अ होमोजेनियस सॉल्यूशन इज अ काइंड ऑफ अ सॉल्यूशन जिसमें सोल्यूट कंप्लीटली डिसॉल्व होके सोल्यूट और सॉल्वेंट एक हो जाते हैं, देन दे बिकम अ सॉल्यूशन. When we say that that's a homogeneous solution, मतलब ये कि कोई भी रेसिड्यू नहीं बचता उनमें. However, अगर उसी एक स्पून की जगह पे मैंने 2 स्पून डाल दिया इसमें नॉर्मल वाटर में, तो देयर आर चांसेस कि नॉर्मल टेम्परेचर पे सॉल्ट पूरा डिसॉल्व नहीं होगा एंड वील हैव सम काइंड ऑफ अ रेसिड्यू. हाउएवर, अगर हम ये चीज़ ऑब्जर्व करें और हमने उस पानी और नमक के सॉल्यूशन को थोड़ा हीट कर दिया, तो देयर आर चांसेस कि जो पूरी की पूरी नमक है वो वाटर में डिसॉल्व हो जाए. अब ये सोचने वाली बात है कि ऐसा क्यों होता है, या what leads to the solution absorbing more common salt in itself. When we heat this solution, what happens technically is the hydrogen and oxygen bond of water extends. When we say the bond extends, what we mean is the bond length increases, and as the bond length increases, more sodium chloride can be absorbed or can be replaced within the existing hydrogen and oxygen bonds. That is why when we heat a solution containing water and common salt, the amount of salt that dissolves in the same amount of water increases. Similarly, molality is when a unit mass of a mole or when one unit mass of a solute dissolves in a solvent, it is called as molality. Now my dear students, you might be remembering, or rather you should remember, what we did in earlier class was when we went on to describe certain functionalities of atoms like atomic number, atomic mass. Then we had to incorporate the usefulness of protons and neutrons. Atomic number was the number of protons in the nucleus of an atom, and since an atom to exist in an independent state, it was necessary that the atom is a neutral particle. Hence, atomic number is the total number of protons present in the nucleus. At the same time, what would be atomic mass? Atomic mass would be the total sum of the total number of atomic number and sum of the total number of protons and neutrons in the nucleus is termed as atomic mass. and why did we not take into consideration the electrons? The answer to that question is because of the Aufbau's uncertainty principle, we ourselves as students or teachers or chemists or scientists or researchers are still not sure which electron would jump into which orbital at what time. Rather, with how much energy will the orbital be in, how much energy in the orbital would lead to the jumping of electrons. Keeping these things in mind, when the journey of our researchers in the earlier times continued, there was a very interesting physicist and a chemist called as Planck. Planck was a scientist who normally related himself with electromagnetic energies or magnetic energies or electricity fluxes. So what he said was the electrons are jumping from one orbital to the other based on the energy of the orbitals. As a result of which, what happened was an orbital A had an energy of, let's say, 3 joules, and orbital B would have an energy of 6 joules. So these kinds of specific energies in a specific orbitals led to the establishment of energy state, which means orbital A was typically called as an energy state, orbital B was called as an energy state. Where did we reach from this is Planck was able to explain and detail out the fact that any electron which has a given energy with itself will be found in the designated energy state. However, so one pause.